All right, we're back. We're still on page 193. We're doing the second part of this problem where we have a particle moving in a circle. It's going to start at a random point, not the top, bottom, left, or right. And it's going to go a certain direction. So in this particular problem, and the one we just did, we went counterclockwise. Counterclockwise is your dream scenario because the unit circle just like works that way. Now we want to go clockwise. And if you remember the scenario, the center is 3, 8. We're going to start at negative 610 ultimately, but not to begin with. To begin with, we just like get a sense of the situation. And then the radius was radical 85. So we can borrow that. So, all right, should I just duplicate? Can I just duplicate this? Hold up. I'm going to try to just duplicate. Nice. Okay. Let's take this. All right. So we know that this is going to be the point 3, 8. And we know we want to start kind of over here at negative 6, 10. All right, that's our goal. Now to do this, we have to go clockwise. So clockwise is like this. So I need to write a base set of equations. And I can use any base set of equations that makes this path and that direction. So I could say that I want to start here and then go in this direction, in which case at t equals 0 will be here, at t equals pi over 2 will be here, at t equals pi will be here, at t equals 3 pi over 2 will be here, which means the angle that I'm looking for is going to be a little more than pi, right? This is pi and then plus a reference angle. I could make my equation so that I'm starting here and going this way, right? So I'll be here at 0, I'll be here at pi over 2, I'll be here at pi, here at 3 pi over 2. So what does that mean? That means that the angle I'm looking for is going to be a little bit past pi over 2, which is maybe the weirdest thing because that's not usually how it works. But do what works, because in parametrics, usually what you think works will work, and that's kind of amazing. I could write parametric equations that start here and go this way. So I'll be here at 0, here at pi over 2. The nice thing about that is if this is t equals 0 and this is t equals pi over 2, then to get here, I just need to know this angle. So I think those are the ones that I'm going to use. So my base set of equations. So I start with a base set of equations. They're just to get things going. So my base equations, I'm going to use x, y, 3, 8. All right, now I need to think. I'm going to start here. So x is starting at a minimum, right? There's the minimum, the middle, and the maximum. Starting at a minimum, that's got to be negative cosine. So minus radical 85 cosine of t. I'm going to assume it takes 2 pi because I wasn't told otherwise. And then sine. If I use cosine, I'm using sine. So y is going to be sine, but what kind of sine? Start in the middle, go to a maximum. That is actually positive sine. So radical 85 sine of t. All right, so with these equations, here's how my circle works. I'm going to be here at t equals 0, and I'll be here at t equals pi over 2, and so on, right? So that's what we got with this set of base equations. I wish I had like a lot more space. I don't, but I really wish I did. Okay, so now I need to figure out the angle. I already kind of know the angle because we did the work last time. So this is a radius. And then what I'm going to do is, I don't know why I didn't zoom way in last time. Drop this down. This is a right triangle. So we're going to use the right triangle. So this distance is 9. This distance is 2. I called it alpha last time. So alpha is just tan inverse of 2/9. But in this particular case, the angle that we need is alpha, right? Because we're starting at t equals 0 here. By the time theta, the parameter, is arctan of 2/9, we'll be here, and that's what I want. And then I just want to continue. So I actually think in this case, I can write my equations. You know what I'll do? I'm going to shrink down this picture like a lot. All right. And put it there. And I will write this underneath here. So these are my equations that are going to start at -6, 10. right? Because that's the ultimate goal. So we have, basically, we're just going to copy the base equations. I'm literally going to copy the base equations. So duplicate. Oh, I always duplicate. I always think to do it after the fact, after I've already made my brace. Okay, so what do I need to modify? Well, everything is the same except when t is equal to 0, I need to make sure that I'm getting arctan of 2/9. And the way I do that is just take this and add arctan of 2/9. So plus tan inverse of 2/9. That's going to do it. Plus tan inverse of 2/9. I think that these are going to work. And then I guess t should be greater than or equal to 0. I think that's going to work. I'm going to do the problem again. I'm going to do it in a slightly different way so that you can see that the choice of base equations is important, but like only what? What am I trying to say? I don't know. It's important, but it's more important once you make your choice of base equations that you like follow through. I'm going to use base equations that start, I'm going to have them start here and go this way. I mean, I have no choice about which way I go, right? So we're starting at the bottom and we're going this way. So this will be t equals 0, pi over 2, pi, 3 pi over 2. So starting here and going this way. All right, so think about that. X, Y. So I don't care about offsets or anything yet. I just care that I'm going to start here and go this way. So X starts in the middle, goes toward a minimum, so it's negative sign. So it's going to be 3 minus radical 85 sine of t. And then y starts at a minimum, so it's got to be negative cosine. So this will be 8 minus radical 85 cosine of t. Those are my base equations. So with that, I get a circle. Okay, not a good enough circle to be a circle. Circle, come on. Circle, are you kidding me? One more. Yes, okay. We get a circle where this will be t equals 0. This will be t equals pi over 2, right? Because we're going this way. Okay, so you need to know that. I'm going to shrink this down again. Shrink. Nope. Shrink. All right, maybe there's like a limit to how much I can shrink it. Get small, whatever. I'm not going to shrink that down because it doesn't want to be shrunk. In the event that this is what's happening, right? 0, pi over 2, then to get to this angle, I'm going to start at 0. I'm at pi over 2, and then I have to add alpha, pi over 2 plus alpha. So I'm going to offset by pi over 2 plus alpha. So I'm going to say that my actual equations, and then I'm going to count, I'm like basically done. I'm going to go to GeoGebra. I'm going to like make it happen because I think like, why not? But I could understand if you were tired of this video getting out of here. Although I feel like every time I say that, I then realize that I got it wrong. So I got to offset by pi over 2 plus alpha, which is the arctan of 2/9. So like, you know, you can go, or you could stay. It's up to you. I think both of these are going to start at negative 610 and go clockwise. I think that's going to happen for both of them. So, and let's say t is greater than or equal to 0. T greater than or equal to 0. Okay, let's go. So if you're done, you're done. See you later. Otherwise, we're going to GeoGebra. We're going to make this happen. So GeoGebra Classic. Should be getting pretty good at this by now, I think, if you're actually doing it. All right, here we go. Curve. I'm just going to type them straight in. 3 minus square root of 85, which I should, you know what, let's be efficient here. Let's say that a is equal to square root, let's say r because it's the radius, square root of 85. Okay, and then I'm just going to use that. I'm going to say that a, like the first offset, actually, I'm just going to say a is arctan of 2/9, and then I can just use, what is this degree nonsense? I don't want that. Let me go to the 3 bars, go to settings, and then click on, this thing is actually the algebra one. I don't know why. Angle unit, radians, because we're not lunatics. I don't know why that's the wrong thing right there. I don't know if that always is, it seems to like interpret it correctly. It's getting really windy out, getting nervous about that. All right, curve. Here we go. 3 minus r times cosine of t plus just plus a, because that's our offset, comma 8 plus r times sine of t plus a. And then t is the parameter. I need to go from 0 to 2 pi. All right, let's see. So it's kind of like a moment of truth situation, right? Where, and I think I say that a lot actually. I need to do B is the name of the curve. B of V, it's gonna make a slider for V. I'm gonna change this 0 to 6.3, which is like a little more than 2 pi, and go to 0. And when it's 0, I'm at negative 610, which is exactly what I want. And I'm going clockwise, so perfect. All right, let's try the other one. So I'm gonna hide all of this. Should I duplicate this? No, I think I should just type it again. Curve 3 minus r times sine of t plus pi over 2 plus a, right? So that's our offset. And then 8 minus r times cosine of t plus pi over 2 plus a, comma, t, comma, 0 to 2 pi. And then we'll really know what's happening when we do c of v, and we go to 0. And at 0, we're at negative 610, which we should be. And if we hit play, we're going clockwise. So we got it. So that, I only did it, well, I did it 2 different ways because I wanted you to see that the base equation that you pick will determine what angular offset you need, but it's not unique. Like you can have different choices. And the different choices you make are gonna determine, your offset and everything. So I'm gonna stop this here. I hope you found this helpful. I will see you in the next video.